Here for a vaccine reality check is Dr. Carlos Del Rio, professor and executive associate dean at Emory University School of Medicine. Dr. Del Rio, welcome. Good to have you with us. You have just heard from a couple of CEOs. You have just heard from Dr. Fauci, the head of research at J&J. A lot of them are very hopeful that we will have some kind of vaccine in some form of distribution by the end of the year. Are you?
Yes, I have to say the same thing that Dr. Fauci said. I am cautiously optimistic, but as you mentioned, we are developing a vaccine at a pace that has never been done before. The time that took between isolating the virus for the first time, identifying the virus, and getting a vaccine injection to the first human was only 65 days. That has never, ever occurred before. So trying to think that a year after a virus has been identified, we will have a vaccine ready to deploy and ready to go into massive distribution. It's simply mind-boggling to me. And if this happens, it's great. But again, I just have a lot of I have to be a little cautious and say I hope it happens, but I want to be sure we do it the right way.
Yeah. Let's go back to earlier in this week where Moderna came out with some very preliminary results regarding its attempted vaccine that showed some immune response in 8 of the patients who were enrolled in this study. 8 out of something like 45, says the New York Times. How encouraged are you by that? The market was certainly on Monday, but then that wave of enthusiasm seems to have receded.
Well, I think that we first need to understand how vaccines and how medications are studied. You have a preclinical phase in which, the vaccines are given to animals. Like there's a study recently from Harvard looking at primates, looking at a response in primates. Then if all goes well, you put it into a phase 1 trial. Phase 1 is really about safety and a little bit about immunogenicity in a vaccine. That's what Moderna completed, the phase 1 with their vaccine. We did that here at Emory, and so did colleagues in Washington State at Kaiser. So it's a small group of healthy individuals that are receiving the vaccine just to see if it's safe. And then you take a few of them and you see if it's immunogenic. If that's the case, then you take it to phase 2, in which you give up to the vaccine to a greater number of individuals. Now you're really focused on immunogenicity. And what you're trying to do is determine the dose you're going to eventually use in a phase 3, a small dose, a medium dose, a large dose. So you try to determine which is the best dose in the sense that you have less toxicity but still greater immunogenicity. Once you figure out what the dose is, then you take that to phase 3, which is you take the vaccine and you give it to individuals compared to individuals that don't get the vaccine, the classic placebo randomized study. And for that, you need thousands of individuals, probably 30,000 individuals, 15,000 getting vaccine, 15,000 not getting them. And you follow them for 6 months or so. And during that time, you see if the vaccine actually produces protection from the disease. And that's called the efficacy phase. So what we completed on Monday is the first phase 1. I think about it as going up Everest. You just got to Camp 1. There's a long road ahead to get to the summit.
That was a fascinating description of the process, and that the Moderna results were really focused most prominently on safety, and that efficacy and immunogenic response comes a little bit later. Should we draw any conclusions from the fact that it appears that the massive amount of money that the federal government earmarked for the AstraZeneca program in collaboration with Oxford, does that mean that one is the better bet compared with Moderna's, Moderna's got $493 million, Johnson & Johnson $500 million? Does money tell you anything about who's farthest along?
What money tells you is that developing a vaccine is very expensive, and it's something like a company like Moderna cannot do on its own. You need a lot of cash, you need a lot of backing, and quite frankly, a lot of vaccine bets don't go well. Merck had a very strong vaccine program around HIV, and it no longer exists because simply after putting a lot of money, they couldn't get an HIV vaccine. So developing a vaccine requires a lot of money. It's not easy to do. And as Dr. Fauci says, we need to have several shots on goal. We need to have several candidates out there. They're very different. The Moderna vaccine is an mRNA vaccine. The AstraZeneca vaccine is a vector vaccine. It's an adenovirus vector vaccine. The J&J vaccine is an adenovirus vector vaccine. They're different types of vaccines. And after that, you need to look at all of them, and you hope to have not only a lot of shots on goal, but hopefully a lot of those shots will be goals, because probably you're going to need more than one vaccine in order to tackle this pandemic.
So it sounds like it's quite well, I don't want to get ahead of ourselves here, Dr. Del Rio, but it is possible that there could be more than one vaccine. Then comes the hurdle of getting it into getting whatever number of vaccines are into wide production, into wide distribution. Tell me about that process, how long that takes, and whether you suspect that there may be significant subsets of the population who just say, I want no part of any vaccine because I don't believe in vaccines or I'm afraid of this one.
Well, I think you're talking about two things. The first thing is you have to produce a vaccine. And production of a vaccine, again, in this doses we're going to need this time around is not billions, but probably billions of doses, is going to require not only using the current infrastructure and vaccine, but probably developing new companies, bricks and mortar to create new manufacturing facilities. And that could probably start right now, the manufacturing facilities, but you're still going to have to then make the vaccine. It's billions of doses. And I think this is going to require an effort no different than during the war in making aircraft and tanks and other things. You're going to have a major effort to produce massive doses of vaccine. And then you're going to have to deploy it. You're going to have to deploy it to the populations that need it. You're going to have to deploy it globally. There's no point in just vaccinating the U.S.
Right.
This virus has shown us that it doesn't respect borders. So you need to get it everywhere. And then you have the issue of the people that don't want a vaccine. And I will say, we have to do a lot of work to try to convince people that it's an important vaccine. But hopefully what we'll get, once you have a vaccine and you have contagion, I will tell you, I don't think you need a vaccine that has 100% efficacy. If we can get a vaccine that has a 40% efficacy, plus people getting infected between now and then, the percent of people infected in the population will probably grow somewhere between 15 to 20% over time. I think you may have enough. You need about 60% of people in the population infected or immunized in order to get what we call herd immunity. So if you get 40% of people vaccinated and 20% got the disease, you will get to herd immunity. So that's where we need to get. We don't need to get 100% of people vaccinated. Herd immunity will then help us.